Hello friends, welcome back to another video. As usual, I am Amoka Bandrikaldi. Today let us discuss about a UART. So by using a UART, we can control any of the devices using a UART characteristics. So that is the topic of this today's video. So the whole topic is like, if I am sending A, the voltage will be provided for one of the pins. If I am sending B, the voltage will be retrieved. Okay, the program has been coded in such a way that if I am sending A, the voltage will be going for certain pins. So here, if I am sending A, the voltage will be set to one of a pin, that is 0th pin. And if I am sending a B here, then the voltage will be retrieved for that respective pin. So this is the overall picture of a video. If I am go on sending a character, the 0th pin of a port 1 will be high always. If I am sending B, apparently it turns to 0, that is voltage 0 is going for a 0th pin of a port 1. This is all about this respective video, what you are going to see in our today's session. So let us jump to the coding part, how exactly this has been done. So here, in order to understand the UART configuration, you can watch this video. So I am going to have a quick run and I am going to make this logic which is going to work fruitfully. I am going to explain this logic in an easier manner. So the first one is the header file. We are going to include a LPC1768.h. So this is the one which I have been using. So this is a variable which have been used to store the received data. So here I am being configured. So next I am using a UART 0 and I am configuring the TX D0 and RX D0 to work as a receive and transmitter of a UART. So this will be connected to the respective pins. You need to go through a data sheet in order to configure this one. So again I am using a FCR for enabling the FIFO pin, and next one is a LCR. It is a data format. I am enabling a 8-bit data. We are transmitting 8-bit data, one stop bit, and I am going to enable the DLATch. So the next one is a baud rate calculation, 9600. So after having a calculation, you can convert that respective number into an X. For baud rate calculation, you can go for this, watching this video. So finally we are having a LCR again. So after having formatters, initially the 8-bit data, one stop bit. So later we are going to disable the division latch and we are going to store the new DLL and DLM value. In order to do this feasibility, again we are sending the LCR. So these are all the things which are being just done in a previous video. You can just make a summary of it. So here I am adding 2 extra lines. I am defining pins which is under a port 1 under 0th pin. So here I am been selecting a pin select 2 and I am making all the pins ranging from 0 to 15 of port 2 to work as a GPI. So that is the why I am going to have a pin select 2 here. And next I am going to make a 0th bit of the port 1 to work as output port, because I am sending some voltage to it whenever the character A is received. So again I am having a one endless loop. So after this, it is not essential. I am just checking the status. LSR is a resistor which is going to provide you a status of a transmitter and a receiver. So one thing I need to just make it clear here, RBR is a receiver resistor, receive buffer resistor. So receive buffer resistor, and THR is a transmit hold resistor. So whenever we are going to transmit any data, the THR is a resistor which is going to hold that 8-bit data. And if we need to receive any of the data, then we need a RBR. So in an LSR, the very first bit is a RBR. So first bit, that is a 0th bit, is RBR. If this bit is high, so if this bit is high, then we can understand that the RBR is full. That is, it is having some data. You can can just retrieve the data into any of a variable. So this is all about the RBR. If the first bit is equal to 1, we can just suck the data from an RBR. So that is what I am doing here. Whenever the LSR 0th bit is 1, so here I am going to get a status ending with the 0th bit. So here I will be getting 1 or 0. If it is equal to 1, it is going to enter here at the very first line. RBR is 1. Then we can just retrieve the data, and I am going to store that into an REC variable. So later I am just taking the status of a LSR and I am checking whether THR is empty. If the THR is empty, you can transmit a data. So you can transmit data using UART 0. So while transmitting, I am just transmitting the received data from a keyboard. Received data. So this is the REC which have been retrieved by an RBR system whenever the first bit is high. So whenever the 5th bit is high, we can understand that THR is empty. If the THR is empty, you can transmit the information. So I am just transmitting some of the letters from a keyboard. REC is going for a THR. If the received letter is equal to A, I am passing a high voltage to the 0th pin of port 1. So if I am transmitting the B letter B, then I am making 0 volts to the pin 0 and port 1. So this is the commands FIO clear, FIO set, FIO dir, pin select. These are the 4 resistors. In order to understand how to configure all this pin select, FIO dir, FIO set, FIO clear, you can go for this video. So this is all about the coding part. So let me execute this. So the coding says that if I am pressing A from a keyboard, it should provide some of a voltage to the 0th pin of a port 1. This is what I am doing here in a UART. I am going to run this one. So for run, I need to press a run button which have been provided here, or you can press F5. So if I am, okay, let me show how to have this peripherals first. Go to GPIO fast interface and I am using a port 1. So here 1 states that I am using port 1 as output port. So you can see the peripherals of a UART, what exactly it has been happening in an UART with a step-by-step execution. So this is a UART. Let me execute a step-by-step. Okay, it is running already. Okay, so let me show this again by having a reset option. So this is a peripherals of a UART 0. So let me have a step-by-step execution. So after making RxD0 and TXD0 to work as a transmitter and receiver of a UART. So now I am making a FIFO set. So you can just observe here the FIO FCR is going to be just set here. So you can just see here it has been set. So next LCR value. So this DLAB have been activated and it is going to have 1 stop bits and the word length is 8 bit. So that is according to the data sheet and according to this number. So this LCR have been changed. So after this DLL, I am having a parity, I am having a baud rate calculations here. DLL have been changed to E2, initially it was 0. So again, I am making this port 0 to work as a GPIO. So after executing this, I am making this to work as an FIODR, that is output port. I am making it as an high. So now it is on one endless loop. I am going to execute it forever. So now my job is to check. To give inputs to a UART, you need to select this serial window. Just click on it and go for UART 1. So here you can give inputs called A. If I am sending A from a keyboard, the FIO set should happen at a 0th pin. So let me check whether it is possible or not. So I am sending A. So initially it was not set at, now it has been set at a 0th pin of a port 1. So continuously I am transmitting the data. So you can just see here transmitter empty, transmitter empty. After transmitter is empty, so the new data is going to be transmitted. So soon after having all this A's, so the 0th bit is high. Whenever I am sending a B, apparently it has been turned to 0. So this is a one kind of an application. You can use a UART to turn on any of the devices. You can connect a DC motors or you can connect a LEDs. If you are sending A or a set of a string of a data, you can on or off the devices. So that's it for this video, guys. If you are interested with these kinds of stuff, please do subscribe. If this video is helpful for your friends, do share them, give thumbs up for this video, guys. Thank you for watching. Bye bye.